Okay, let's talk about the first skill needed to be able to start solving equations. And the skill is combining like terms. And it's something that you should have seen in middle school, but it's still something that tends to trip up students now in Algebra 1. And so I want to kind of approach it in a different way. So there's something that I want us to ultimately agree on right here, about halfway down this page. So I want to go through a couple prompts using a really basic real life scenario, and I'm hoping that that helps you understand what like terms are a little bit more than maybe you understand them now. So this is the type of situation you are going to be asked to simplify. And so you have all these different terms, and a lot of times students will look at the first term and then combine it with anything that kind of looks like it. So, well, this has an X, so I must be able to combine it with this, and then I must be able to combine it with this, and I must be able to combine it with this. And so we kind of just take a look at this first term and we just start gathering things that look somewhat like it. And so I really want to break that habit, and I want to approach this in a common sense, like real world way, and see if that helps you understand when you can combine like terms and when you can't. So let's look at this clip art right here. We have 6 friends. We have Jane, Julie, Justin, Julie, Josh, and Justin. So the first question that I have on here is, do we have 6 Janes? So we have 6 kids, and the first one's name is Jane. So does that mean that we have 6 Janes? Well, no, of course not. We know that that's even just like a silly question. We know that we don't have 6 Janes just because the first girl's name is Jane. So, okay, so great. So we've established that just because the first thing is Jane or is something, it doesn't mean that we now just count everything as that thing as well. We know that there's differences. It's not just all whatever the first term is. Okay, so sometimes we kind of look at things like in random in the equation. We might say, okay, I have a y here, and you start combining it with just random things that also have a y. So you must be able to combine those two things because they have something in common. So the real life situation would be if I take a random middle person's name in this thing, do I just start combining him with all these random other things and say, okay, well, I have 6 Justins. Like, just because there's a Justin, do I have 6 of them? Well, no. Again, that's like a silly question. So we know that we can't just go off what the first term is and combine everything. And we know we don't just get to choose a random term or random person in the middle and just combine everything with that. So there's got to be some order or some ground rules to what we can combine and what we cannot combine. So let's just look at this scenario and let's see if we have, let's see if we have do we have more than one of any name? And if so, what name? So is there anyone on any of these 6 friends, do they have the same full name? And yeah, we know right away. We have a Justin and we have a Justin. So yes, we have more than one of these kids' names are Justin. So what we could say is that we have 2 Justins. That's how we combine like terms in real life. We don't really say everything that we actually have. We combine them into things that are exactly the same, and then we tell you how many of them that we have. If I have a whole class of a bunch of kids, I might say, well, I have 17 girls and 10 boys. So I've just taken all the girls and combined them as one like term, and all the boys and combined them as one like term. So in this scenario, we see, yeah, we've got 2 Justins. So that would make sense for us to say, yeah, we have 2 Justins. We know we can group these 2 guys together where the other 4 kids don't belong in that group. And that should be common sense. So something that I want to point out, and this is what I want us to ultimately agree on. If you look at all of these names, I intentionally started them all with the same letter. But we just kind of proved that it's not just the first letter, the first part that matters anymore. It's what comes after it matters equally as much. So yes, it's important that this Jane starts with a J, but I also have other stuff behind it that doesn't look like the same things that's behind the J in Julie or the same thing that's behind the J in Justin. And so in real life, we understand if I have the name Jane, I can't combine that with a Julie. I can't say I have two Janes or two Julies because we know that yes, they both start with a J and yes, they have that in common, but ultimately they're not like terms because what comes after the first letter matters just as much as the first letter itself. And so I want us to be able to agree is can we agree that the first letter and what comes after matters equally? And so I'm hoping just in this situation you understand that the beginning is just as important as what follows. And so if we think of terms as like last names or names, then we should be able to say, okay, well, x and x squared are not the same. Because yes, they both start with x, but what comes after is not the same. So that would be like maybe a Jane and a Justin. We can't combine them. Yes, they both start with J, but what comes after matters just as much. And so the idea is that you begin to see these terms as their name. And the starting part is the first letter, and the exponent is what comes after. And so if I have something like x, and x cubed, yeah, I can combine x and x because they both start with an x and end with the same exponent. They have what comes after them is exactly the same, so we're able to combine these two terms, whereas x cubed starts with an x, but what comes after the x doesn't look the same, so I can't combine them with just the x's. Okay, so let's look at this blue thing in the middle, and then we'll go into some examples. It says, oh yeah, don't forget, the sign in front of the variable or the number has to stay with that variable or number. And so we'll see that here in a couple example problems. But just remember that if I have something like up here in the original problem, this negative sign or this minus sign has to stay with the 4xy. And this minus sign has to stay with this y. So if you have a negative sign or a positive sign, it has to be attached to whatever comes after it. So make sure if you're combining things, you take into account every single sign and keeping it attached to the term that comes after it. So here, for example 1, let's circle all of the terms that could be combined with negative 2x. So the negative 2 tells us how many. The x tells us the person's name. So how many other x's do I have? So I have something here that starts with an x, but it has a 2 after it. And this term does not have a 2. So yes, they both start with an x, but what comes after it is different. So we're not able to say that those are like terms. This one I put in here to kind of trick us. So this is negative 2 x's. This is just negative 2. It doesn't even have an x. So we don't even know, we're not talking about the same thing at all. It doesn't even start with the same thing because this doesn't even have an x. So this is definitely not a like term. This one, yes, it has an x, and so does this. Let me see if I can erase this. There we go. This also has an x, but there's nothing after it. And this has a y after it. So it's not the same thing. This one starts with an x. There's 5x cubes, but this actually has an exponent of 1, and this has an exponent of 3. So if I have the name x1 and x3, those are not the same names. Yes, they start with the same thing, but what comes after them is different. And we already proved in the beginning with just basic names or basic things, we know that what comes after matters just as much. And so we also can't combine these terms. So let's look at this last one. This has negative 2x with a 1. This is negative 8x with an invisible 1. And so this is the only term in this whole list that I could combine. These are the only two things that are considered like terms. So let's look at example 2. It says circle all the terms that could be combined with 8x cubed. So I'm looking for the name x cubed. Has to start with an x and end with a 3 and nothing else after it. So here we have 3x squares. Starts with an x, but it doesn't have a 3 after it, it has a 2 after it. So this might be a Jane, we're looking for Justin's, so that's not right. This is just a number, doesn't even contain the variable x, so we should see that we can't even combine those. They're not talking about the same thing at all, so that's not a like term. This one has x with a 3 after it, which is great because that's what we're looking for, but our original term has no other variables following it, and this one does. So this one we say we just want the x3, that's his name, and if you have x3y, you've now added more letters, and it's not the same name, so this is not a like term. Okay, so let's look at this next example. So again, the name that we're looking for is just x cubed. This is the name that we want. We can't have any more letters after it because we're just looking for an x cubed. So this one has 5x cubed. So here we have 8 of them, so maybe 8 Justins. Here we have 5 Justins, so we know that we can combine those to be 13 Justins. And the way we're showing Justin, or what I'm actually showing you, is x cubed is the full name. Starts with an x, ends with a 3, starts with an x, ends with a 3, starts with an x, ends with a 3. And so yes, this is our first like term of this list. Let's look at this last one. Negative 8x3, x cubed. So what we're looking for is x with a 3 behind it, x with a 3 behind it. And so they're identical names. They have the same starting letter and they have the same thing coming after. So I also know that this is a like term. So those last two terms are the only two like terms in that list. So let's see what this would look like if we actually had an equation, and then we're going to have you do some practice on this. So simplify the expression by combining like terms. So the process is you want to write this out and you want to look at your first term, 4x. You want to know if you have any other names that are x and how many of them, and then we're going to combine the numbers. So the only name I'm looking for right now is x, and this actually has an imaginary 1 as an exponent. So if I look at my next term, I have x squared. Well, my first term doesn't have a 2, so that's not a like term. But I have a 2x right here. And I want to make sure I include that negative sign right there because that sign is attached to what's behind it. So I can combine those two. And then I also have plus 7x. So everything in my boxes right now contain just an x with an invisible 1 after it. So I'm able to combine all of them. So I have 4 minus 2, which is 2, plus 7, which is 9. So I have 9x. Now my next term is 4x squared. Well, I already took care of this one and these and that. So my only option right now is this negative 5. And I'm looking for a name that has x, starts with an x, ends with a 2. And this situation, this negative 5, doesn't even have an x. So these are not like terms. So this doesn't disappear. It just can't be combined with anything. So it stays in the expression by itself. And then this negative 5, there's no other numbers, there's no other terms without a variable, so this guy just stays in the expression himself. And so finally, the very last step is we want to write these in order of the exponent. So this exponent is a 2, this exponent is a 1. So we're going to actually write this term first. So 4x squared plus 9x minus 5. So this is our final answer for this problem. So hopefully that kind of clears some things up and helps you relate it to a real life situation. Just remember that if something starts with the letter X, it's just as important of what comes after it as what it's starting with. And so if we have x squared and x cubed, Yeah, they both start with an X, but what comes after is not the same, so we cannot combine them. If I have an X and an XY, yeah, they both have X, but what comes after it is not the same, so I can't combine them. So it has to be starting with the same thing and ending with the same thing in order to make it a like term in order to be able to combine it.